This is Mark Anderson for Kellogg Community College, and today we're going to look at adding and subtracting radicals. One of the things I have to remind you, though, is that adding and subtracting radicals is much different than multiplying radicals or multiplying, exponents altogether. I want to highlight that x times x is x squared, but x plus x is not x squared. In fact, it's 1x plus 1x, which gives you 2x. But I still get a lot of people who make mistakes when they look at the square root of 2 plus square root of 2. Square root of 2 plus square root of 2 is not square root of 4. You can do that with multiplication, square root of 2 times square root of 2, because of the product property in the previous video. We can make that square root of 4, which is then simplifiable down to 2. But in this case, if we have square root of 2 plus square root of 2, this is like a variable, like 1x plus 1x, which then gives you 2 square roots of 2, which cannot be further simplified, because square root of 2 cannot be simplified any further. There's no number that can divide it, like in the previous video. So what we have is basically you can add radicals together if they function like common terms. So for example, this is 3 square roots of 3 and 2 square roots of 3, which make 5 square roots of 3. Or losing 2 square root of 2 and minus 7 square root of 2 is like losing 9 square root of 2. 5 square root of x minus 9 square root of x is like having negative 4 square root of x. The coefficients in front of each of these radicals act like numbers and coefficients in front of x, like 5x minus 9x is negative 4x, but in this case, it's a root of an x. And here we have negative 6 square root of 2a minus 4 square root of 2a is negative 10 square root of 2a. So everything's fine as long as the radicals act like common terms. And so we have these, this next example is unfortunately the last example that's going to deal with common term issues, because this is negative 4x minus 3x, and that would make negative 7x square root of 2y. So what I'm underlining in blue is the common term that is the radical, and you can combine them using your normal addition and subtraction rules of coefficients as long as the radicals are exactly the same. But then you look at problem number 6 and go, well, they're not the same, so there must be no solution. But it's not quite right, because the square root of 72, as we learned in the previous video of simplifying radicals, can be broken down into the square root of 36 times the square root of 2. So 4 times the square root of 36 is 4 times 6 times square root of 2, or 24 square roots of 2. The 4 times square root of 50, the square root of 50 can be broken down into the square root of 25 times the square root of 2. And that would then make this a minus 4 times 5 times square root of 2, or minus 20 square roots of 2. So the total becomes 4 square root of 2. That is the answer to the problem. Now, this breaking down of these radicals here show you that, or from the previous video, is going to get you that common term that we have and are going to have in each of these problems. So let's continue on looking at these last 4 examples, and these last 4 examples are also going to have common term issues. So here I am looking at the square root of 36y and the square root of 64y. These are different, but what they're going to do is give us a common term once we simplify the radical a little bit. Now what's nice about the square root of 36 is that is a fully simplifiable radical to 6, because the square root of 36 is 6. And then the square root of y is kind of kept inside because the y doesn't have the power of 2 to get out. And this is 6 times 8, because that is the square root of 64 times the square root of y. So we have negative 12 square roots of y plus 48 square roots of y. And that gives you a total of 36 square roots of y, because here we have that common term, the radical of y. Now what we have for problem number 8 is to see that, well, now that we do have a power of y raised to the second power, we can say how many times does 2 fit into 2? It fits in once, so here's my 2y. And left inside is the square root of 2, because this 2 cannot get out. In the second fraction, or sorry, the second radical, we have 3, and this 32, I'm going to split that into the square root of 16 times the square root of 2 times the square root of y squared. Square root of 16 is going to be 4. Square root of 2 is going to stay a square root of 2. And then the square root of y squared, well, the square root of y squared is just y. And so what we have now is we're going to have this negative 3 times 4 times y is negative 12y times the square root of 2. So we have 2y square root of 2 minus 12y square root of 2. That gives us negative 10y square roots of 2. Okay, so we're down to our last two problems here. These last two problems we're going to deal with breaking these down. These two will break down into 3 times the square root of 4 times the square root of 2, or sorry, square root of 3, minus 5 square roots of 3, which can't be further broken down, plus 6 times the square root of 9 times the square root of 3. So this gives me 3 times 2 times square roots of 3, or 6 square roots of 3, minus 5 square roots of 3. There's nothing to do with this middle term there. And this is 6 times 3 times square root of 3, or plus 18 square roots of 3. So now I have 6 minus 5 plus 18 square roots of 3, or 19 square roots of 3. For our last problem here, we're going to have to break each of these down. This is the square root of 4 times the square root of 5x. This here is the square root of 9 times the square root of 5x. And this here is the square root of 16 times the square root of 5x. Or I wrote 15, but you know I meant 5. Okay. So now we can't forget the leading coefficients here. Like this had a 2, this had a minus 3, and this didn't have any leading coefficient other than 1, so we'll put a plus there. So this makes 2 times the square root of 5x. This is minus 3 times the square root of 5x. And this is 4 times the square root of 5x. So now we have 4 square root of 5x minus 9 square root of 5x plus 4 square root of 5x. So 4 minus 9 plus 4 is negative 1 square root of 5x, and we would not put the 1 in front of the radical, like we wouldn't put a 1 in front of x. So that is the simplification of that problem. All right, well, thank you for watching, and stay tuned for more videos about radicals.